Well, thank you for the introduction. Still an assistant professor at the University of Strathclyde, and my work focuses essentially on critical infrastructure protection, threat hunting, cyber deception, and awareness, generally for all critical infrastructures, and the maritime sector is one of them. And when we look at the maritime sectors, the maritime sector, we can see that 58% of cyber attacks are caused by insiders, which is quite a high number for the sector. Bit of an important number here. Current defense system in the maritime sectors yield like a 1.37 million cost a year for security false positives. So when you have defenses and those creates alerts, only 27% of those alerts are real. The rest are your operators looking or trying to identify if the alerts are real, and this is a bit of a problem. And like in a lot of networks, there's a lack of network visibility, and this creates high dwell times. So the average, which is not specifically for the maritime sector, is about 190 days, and that's from breach to containment. So someone is within the network, able to exfiltrate data, able to go around the network before any detection and containment. So that's a very long time. Now, the importance, and I'm sure someone must have already gone through these slides over the previous days. 90% of global trade is maritime, 70,000 merchant ship trading internationally, and of course there's something that's important here, like ports and waterways allow like to project key military power during a crisis, and that's why we cannot have a blockage. And of course the talk from Dr. Kessler before me was quite important, because if you start like doing AIS jamming or like GPS jamming and AIS spoofing, you could end up with blocking ports and waterways. Now, when we look at the maritime domain, when we look at the maritime domain, we only look at a small part of the MTS, because it's intermodal, and very few other sectors are touch points to connection into the nation. So here, when we look at the maritime, it's acting as a nexus, and the reason is all the elements I said in the previous slides, and you've got connectivity to energy, trucking, and rail. So blocking the maritime or a cyber attack on the maritime domain can actually impact all the rest. So that's quite important to take into account when we talk about cyber attacks. And this is one of the domains where we can really see the ripple effects on other critical infrastructures. Now, when we look at ships, they are constantly evolving, and this is something that's quite interesting about the maritime domain. We have new technologies that is being incorporated, new connected systems. We've got a lot of IoT, but there's still a very big cybersecurity issue. Because cybersecurity has difficulties to reach the maritime domain. And this is the same for a lot of critical infrastructures. It's not specific to the maritime, but when we talk about the maritime, we should think about a couple of things. First of all, the large variety of vessels. Usually when we talk about critical infrastructures, they have some resemblance, whereas here we've got like a plethora of types of vessels, we've got a plethora of systems. There's an extremely long lifespan, 30 years, and after 30 years, some of the vessels are refurbished and put back or sold to other companies and sometimes other countries. For example, when the Dutch Navy is finished with their vessels, they actually sell them to Belgium. And there's a lot of unsupported software. We still have like a lot of Windows XP, Windows NT. We know that for example, a lot of companies have been paying to keep support for Windows XP. There's a high human aspect, which is very important when we talk about cybersecurity. There's a high crew rotation, and they might be unfamiliar with software, unfamiliar with hardware, and of course, for the maritime domain, you get like many third parties and subcontractors that will take care of the maintenance. And on the right side, we can see like a picture of like one of the vessels, and a lot of systems, and that's only a small parts of the systems on the ship. If you look at the ship networks, you will see that, like, of course, you've got like information about the crew timekeeping. You will have the payroll. You will have emails. You have like quite often this is actually connected to the crew network where they've got Wi-Fi. They bring their own device. They do their emails. So there's an interconnectivity that is there, and there are two key aspects to think of. Is the fact that we've got current vessels which keep adding onto the attack surface, and then we've got vessels that have like this lifespan of 30 years and that are using outdated software. And often when we talk about security, we forget about one of those aspects. We often focus on one of them. When we look at the systems, we've got like interconnection systems, and we've got Ethernet, the CAN, which is like also used in car. We've got the LIN bus, created by BMW and was like used by Volkswagen, Audi, Volvo, Mercedes. We've got the TSN, we've got serial peripheral interface like a SPI, which is a synchronous serial communication interface used for short distance communication, RS-232, which those ports don't exist even on our computers anymore. And then we've got like NMEA 0183 and 2000. And all of those protocols actually bring their own vulnerabilities, their own flaws. So the CAN network will broadcast without authentication. There's not been any security built in any of those networks. Now, once we've given that overview of the problems with vessels, we need to have a look at attackers, essentially. And the reason we want to know, the reason we want to have an overview of attackers is because, of course, we need to know or understand what we are defending against. And we've got different tiers of attackers. We have the script kiddies that might only send, like download the script and launch it against something and see if it works. They might not have an understanding of the impact or consequences this script might have. We've got like criminal, disgruntled programmers, disgruntled workers. So that might be a worker that has faulted and has been set aside and has still got access within the infrastructure and is able to delete a database or do some harm to an architecture that he or she knows. We've got the crime groups and activists that are there essentially for gathering information. They might be there for IP, they might be there for simply ransomware. And as we go up, we go into the tier 4, tier 5, and tier 6 attackers, where we've got like organized crime groups and state-sponsored attacks. And the organized crime groups might be similar to what Maersk has had to face. And then tier 4, tier 5, and tier 6 might be what Dr. Kessler was talking about on in closer to Russia, where we've got like GPS spoofing. And so when we look at the maritime sector and when we talk to the maritime sector, they feel they're facing these type of attackers, the tier 4, 5, and 6. Not that they're not facing the bottom tiers, right? But the ones the attackers that have the most impact on the maritime sector are definitely the tier 4, 5, and 6. With that in mind, we want to know how feasible it is to attack a vessel. Like how easy would it be to actually attack a vessel? And actually this was really well demonstrated in the previous talk. And let's have a quick look at another approach. A couple of months ago, for another talk, I tried to have a look at Shodan. And if you don't know what Shodan is, actually Shodan is like a browser or like a search engine for essentially open IoT on the internet. And within a couple of minutes, we can find the Norman Flipper. And of course, this information is public. There's no connection that is being made or no illegal connection that is being made here. So we can see the Norman Flipper. We can see that there's an Apache 2.229 Debian running on Debian that is running. We can see that the vessel or the connection is from Telenor, which is from Norway. And if we simply log on onto the IP, we can see that we get access to the COM box, right, which like provides VSAT information. Now, it turns out that version 1.7.0 that you can see at the bottom actually has vulnerabilities. It's not a secure version of that COM box. And if we simply look at the source code of the page, so again, no hacking here, simply looking at the source code of that like command U on your browser, you can start finding status that are actually broadcasted within the HTML, and all of those statuses can be found also from that web page by looking a bit deeper onto the COMBOX page. Now, that's one point, right? We've gathered information. We found a vessel, and if you're an attacker, you want to actually, the first step that you want to do is like gather more information about your target. So of course, we are going to have a look at the Norman Flipper and look who is, what it does, what type of vessel it is. And here we see that luckily, actually it was on the coast of Scotland, where I was at the time. And I was actually pretty shocked with that. So it was not too far away from Glasgow. And from that information, there's a next step that we can do. The next step is who is in command. Actually, if I wanted to start launching a cyber attack, where would I go? I've got information about the COMBOX. What's the next step? Well, I might want to know who's in command, who's the captain of the Norman Flipper, and fair enough. LinkedIn was, of course, the best bet. And here is like actually the person actually said, I'm the captain of the Norman Flipper, ability to send like a message to the person. And I'm not saying that as a captain, you shouldn't have a LinkedIn profile, right? All I'm saying is that you can start correlating as an attacker information together. And these are the first step an attacker would take. And compile all of that information and start launching your cyber attack. And this could be a simple email to the captain, an email to the crew members, seeing if anybody clicks on a link that would allow us to infect their computer, and in turn, infect like the system of the Norman Flipper, or like create like I'd call that a supply chain attack, but infect the computer, infect a USB key. The USB key then gets plugged in somewhere on the Norman Flipper, and then the USB key gets plugged in somewhere within like the port, and again we start getting like all the links in the chain coming together. So what can we do better, right? Essentially, the question at this stage is where do we go? Well, as I said at the start, we've got to look at two things. The first one is the legacy infrastructures, and the way to do this, is to take a small shortcut. And quite often people say, let's not take a shortcut on cybersecurity. I'll say at this stage, when you're looking at a legacy infrastructure and a disparate or heterogeneous field like the MTS, you want to take a shortcut. The reason you want to take a shortcut is because at some point, disaster is going to strike. And the best way to take a shortcut is to have a look at other critical infrastructures, learn from how they have implemented security on legacy systems. Some of it will not work, but some of it will allow us to bypass reinventing the wheel for the MTS. So I'm not saying take a shortcut on the cybersecurity, I'm taking a shortcut on the processes. Let's not reinvent the wheel for cybersecurity in the MTS. Let's have a look at what has been done elsewhere, and let's use their techniques and practices and apply them to the MTS. So establish processes and do not jump guns. There's no need to jump the guns. We cannot go and say, let's reinvent everything. Then we've got to look at the current infrastructure. And in that case, we need to start looking at security by design. Not only do we need to protect the boundaries, we also need to protect in-network threats. Quite often, when we look at current infrastructures, they are protecting the boundaries of the network. They're placing the firewalls, an intrusion detection system, and so on and so forth, but we don't know what is within the network. So taking a step back, we can look at the human, right? Because at the center of all of that protection, we've got the human. And there's a lot of humans when we talk about the MTS, essentially. And we've got various positions that are like people that will be working on boats, people that will be working on ports, people that will be working on systems or hardware that will interact with the boats or with the port authorities. And we need to take this into account. We need to remember that all of those operators, all of those people are human. So the best training that we can provide them is our best practices, similar to washing hands. They need to understand consequences, and they need to have an adapted training. And I'm talking about a very simple training here. I'm not talking about training them to become cybersecurity expert, because this is not going to work. A while back, one of the NHS proposition was actually to train one nurse to become a cybersecurity expert and to help other nurses. This is never going to work. We need to provide people with appropriate training. If you're a port operator, all you need to know are the very, very basics. And then you need to know who to call in case you see something wrong. You don't need to become a cybersecurity expert. That's for the legacy system. Those are for the people that are currently working on the MTS. For the people that are currently in training, that are not in the field, then like through maritime universities, we should provide them with an introduction to cyber threats. The reason is that they are the next ones that will come and work onto those multi-million-dollar vessels. They are the next one that will walk and work with all that interconnected systems. So simple questions to answer or to provide them with is, what does a threat look like? Who to contact in case of an incident? And what is the impact of a threat? These are very simple and basic elements, but they do a difference. We've conducted surveys across various critical infrastructures, and if you provide answers to these three questions, and the person knows what happens to these three questions, they take this seriously. Why? Because the impact threaten their jobs, threaten the companies. The who to contact in case of an incident, if you see something, report it. It's as simple as that. You don't need to become an expert. And what does a threat look like? This is important so that they are able to recognize and differentiate a threat from a malfunction. So these are the three questions that can help the MTS for starter. Once we have answered all of those questions and we've provided training for these 3 questions, we can start looking at tabletop exercises, cyber attacks playbook, breach decision making. But again, those need to be targeted. Port operators, not everybody as a port operator, like port authorities, need to know how to handle a cyber incident. But the people responsible for the IT infrastructures or the OT infrastructure must understand this. Similarly, we are moving towards cyber ranges, like the French Naval Academy, for example, as an excellent cyber range through the European Foresight project, where like a full maritime system is replicated. There are common attack playbooks that can be launched and metrics that can be gathered. It's important to provide metrics during training so that the trainee knows its level and at the same time improves, because these need to be iteration in terms of training. So the most important part of the training is do not burden the trainee. And that comes back to what I was saying at the start. Everybody has a position, not everybody needs to become an expert. And quite often when we see cyber trainings, people want everyone to become a cyber expert. This is not the case. We do not need to burden people. We just need to remember operators are humans and they will make mistakes. But if they make a mistake, you want another operator to be able to actually catch that mistake. That's simple as that. Now on the technical side, it's a bit different because again, similar to people that we had in the field and people that we had in training, we have legacy systems and systems that are current. For the systems that are current, quite often we have like a lot of border intelligence, and we rely on that border intelligence to navigate the threat maps. And this is excellent because you have your network protected. The attacks are detected at the border, and then they are transferred to your SIEM or an ELK stack or wherever. But those attacks need to be transferred somewhere that someone can look at it. And that person must be dedicated to looking at attacks. Quite often we see in critical infrastructures, this is the responsibility of an IT department, and this doesn't really work because they have to manage the infrastructure, they've got to take care of alerts, there is a lot of false positives. So again, we are burdening the human. We need to make sure that those alerts are provided in a format that is understandable to the person, but at the same time that are concrete and that are actionable. So now the SIEM allows you to aggregate all of those disparate sources of information, but you still get the flood of alert, and you might still miss context about who is attacking, what's currently impacted, when has it happened, where is this happening, and how is this happening. And we can think about this when we talk about like security operators and IT that are looking at alerts. They are essentially in modern architectures trying to find a needle in the haystack, and the haystack is often quite big because we've got like all these interconnected systems. And so when we get all of those alerts and those false positives, it's very difficult to identify which one someone should follow. So the current security makes it extremely complicated. The current security systems make it complicated on a SOC operator to actually collate all that information and answer these questions. Now, there's one solution, and I think another speaker has been talking about this previously, is cyber deception. And cyber deception is an excellent solution for this. It's provide active defenses, so you're able to respond to threats. You can engage with the threat. And what is most important is that you want to deny the position of an attacker. So how do we do cyber deception? Cyber deception is placing decoys within a network. You essentially place fake systems, fake data that report an alert when the decoy is being tripped. So it's more an active defense than a passive defense. Currently, like if you think about your firewalls and intrusion detection systems, they are essentially passive. They are waiting for an attack, and they essentially reduce that probability of or minimize the effect of an attack. Deception, on the other hand, is something that you will deploy within your network and will actively engage with the attacker. The assumption behind deception is that you are going to get breached at some point. And this is very important because you want to know, you want to assume this, that it's not a matter of if, but when. So you want to increase the effort on the attacker. You want to waste their time. You want to increase like the detection accuracy, like because you know that when a decoy raises an alert, there is someone lurking on your network. Now, often people think about deception as something that is complementary, but deception needs to be implemented to defend from people that might have clicked on the link unaware and given access to someone onto the network. And military deception has been used for ages. And for example, the first treaty, and you might know it is the Art of War from Sun Tzu. It's focused on tactics. And now deception are fully fledged doctrines, right? And here we can see the picture of a Q ship to combat German submarines. And it was looking essentially like a civilian vessel or like a decrepit Trump steamer. And the idea was that it would conceal heavy guns. And when a submarine would see one of those ships, they would actually come back to the surface because they didn't want to actually use one of their expensive torpedoes. So they thought, well, let's go up and gun the ship. And once the U-boat would surface, the Q ship would actually run the Royal Navy white ensign flag, and they would then get their machine guns out and actually get the U-boat under fire, essentially. And I can't remember the word in English, but sink, exactly. So sink the U-boats. So those military tactics or military deception tactics have been used in the past. Now, how do we use deception in a network, or what does it look like? Well, you can think about deception as this pinhole view. You understand the network, the attacker does not understand the network. So from his perspective or their perspective, they don't know exactly where they are. They might know what the network looked like. So if you think about it, I'm in my flat, I know I know the noises of my flat. So if someone is in the kitchen, I'll know that someone is in the kitchen. An attacker that enters a flat, or like a robber that enters a flat, will have an understanding that there's probably going to be a kitchen, there's probably going to be a bathroom, there's probably going to be a living room, and so on and so forth. They just do not know where they are. And it's the same on the network. So it gives us like this ability to start providing essentially elements for the attacker to think of. And we can cover the full network. We can open certain doors, we can close certain doors of the network, provide the attacker with certain keys. And that allows us to shape the view of the attacker and to reduce the dwell time, because now you've turned the table on the attacker needs to be 100% of the time right when he accesses a system. Now, if it was us at Lubovis, we actually cover the entire network. So this is a maritime use case, and we would recommend to cover as much as your network as possible. And if you're interested in deception, you can come and talk to us. I'm happy to provide you with some information, but the idea is to be able to cover the entire MTS. The reason is that there's so many entry points, you want to be able to cover as many as possible. The next step is actually deploy deception at every single stage of the attacker's kill chain. You want to lie to the attacker, you want to misdirect the attacker, you want to divert the attacker, deceive the attacker, obfuscate, disrupt, delay. you want to waste an attacker's time. And the reason you want to waste an attacker's time is because it gives your team enough time to start implementing defenses or to learn about the attacker. So how do we implement deception? Well, the easiest way is honeypots. They're plenty free over the internet. You get like Compot that can be used for ICS. You get other honeypots that can be used for your network, like for your IT network. And they're essentially standalone machine, and they will be low or medium in traction, and they will waste your attacker's time. This is a very simple way of detecting someone within your network. And if you want to try it out and have something simple, one of the simplest honeypot possible, you can simply open port 80 on a couple of machines using like a tool like Netcat, and essentially it's gonna create a small listening port onto your machine on port 80, like you would be running WAMP or like a web server. And when someone accesses that web server on your machines, you'll know that someone is actually trying to do something. It's at least going to raise an alert. It's going to provide you with an IP, and that might be a computer that is infected. So we provide a full service, but if you want to try it out, if you want to try to deploy deception within your network, and you want to deploy honeypots, please come and talk to us. Like I'm happy to help you deploy honeypots, because I think they have an added value for every CISO to know that someone is within your network. This cannot be, it's a very simple value proposition, but a honeypot provides added value. And what you want to learn through the honeypot is essentially, can you detect that a user is accessing thousands of files onto your network? This is what everyone should be thinking about. Can you detect that a user is accessing systems? Can you detect an insider threat? And can you pinpoint that user on the network? And deception, or simply called honeypots, can help do this. And these can be placed within a vessel. These can be placed within an OT infrastructure, within an IT infrastructure, and so on and so forth. And I know that I've covered quite a lot of ground here. I've moved from threats, or how to carry out a very simple attack, to the training, and then to in-network threats. I hope there was like some kind of story, and you managed to see the story across. But there's still a long way to go into the maritime sector. There are effective shortcuts that we can take to improve the security of the maritime sector. There are those are iterative solutions. So when I mentioned taking a shortcut and implementing what is implemented in other critical infrastructures, those needs to be built upon. It's not something that you just implement and you leave it there. When I talk about training, the best practices only, we just need to teach best practices and understand that operators are human. And then in terms of technical, again, best practices like security as security from the start, essentially, looking at border intelligence, but let's not forget like in-network threats.